Fourth objective is a distributive practice. You know, this is the first part of our chemical reaction, so each part will have its own separate DP section. First skill that being tested on is to recognize ionic versus molecular. So tempting to start naming and writing formulas. Be careful, reader. I just want I or M. Ionic compounds are built of metals to nonmetals. Molecular compounds, we hear prefixes in their names. They're when nonmetals combine with nonmetals, ionic or molecular. All the skill is recognizing if the first element is a metal or a nonmetal. First one is nickel 1 chloride. Nickel, point to it on the table for us. Nickel indeed is a metal lying to the left of the border. Metal plus a nonmetal is ionic. Carbon, tetraoxide. Well, I'm hearing prefixes due to the molecular nature. Carbon and oxygen are both nonmetals. As is N2O4, dinitrogen tetraoxide, molecular. And barium oxide, barium's a metal, I would label this ionic. Number one thing that will happen is we'll start writing formulas and names. We're just not being careful readers for the directions. We want I's or M's in this question, ionic or molecular. Number two is going to ask us to do a mole map question. We'll need a calculator. How many hydrogen atoms in 5 grams of ammonium phosphate? Ammonium, a polyatomic ion, ammonium, NH4+, phosphate, PO4 minus 3. Ammonium phosphate built of 2 polyatomic ions. So I'll start by writing my number, my label, 5 grams of ammonium phosphate. NH4 taken 3 times PO4 based on charge. My first conversion is going to need a molar mass of my compound. I'm heading from the scale into the mole. On our mole map, the conversion requires a formula weight. Let's add together formula weight. I'm counting nitrogen, which weighs 14, but I distribute through. There's 3 of those, so times 3. 14 times 3 for the N, plus. Hydrogen weighs 1, but 4 times 3, there's 12 of those, so plus 1 times 12. Phosphorus is 31, plus 16 times 4, 4 units of oxygen. I get a total sum of 149. Number unit label, so NH4 taken 3 times PO4 times an Avogadro's number of whole entire compounds called formula units. When polyatomic ions group together, they're formula units in every 1 mole. And now, peeking inside of that formula, I count 3 times 4. I'm counting 12 hydrogen atoms in every 1 formula unit of our compound called ammonium phosphate. 1, 2, 3-step conversion by the time I'm done. Start by typing in your 5 grams. Divide by the molar mass we found of 149. Multiply by Avogadro, and multiply by the number of hydrogens times 12. So grams divided by molar mass times Avogadro times 12. The number of H's, we get 2.42, look to the end of the screen, times 10 to the 23rd. 2.42 times 10 to the 23rd hydrogen atoms. An old mole map problem. Number 3, what is the density of trisulfur hexaoxide at STP? Remember the round little buddy for density. Density is defined as mass over volume is big D. Density is mass per unit volume. For us, molar mass is used for M. V is molar volume, a constant in chemistry, 22.4 liters. And D will come out literally in a gram per liter unit. So to find density of trisulfur hexaoxide, I need to take its molar mass divided by the molar volume, and we'll come up with density. So I've got to do some adding of formula weight. Sulfur, who weighs 32, but there's 3 of them, plus oxygen 16 times 6 of those, I get a formula weight of 192 grams. Molar mass over molar volume finds our density. 192 divided by 22.4, I get 8.57 grams per liter of S3O6. A density problem off of an old mole map. Now friends, in number 4, we're being asked to draw an electron dot structure for a polyatomic ion. We have not practiced that skill, so I'll need to replace that question before we test. For right now, let's cross off number 4, freebie. And the last one we'll work is an empirical formula problem. Suppose we want to calculate a molecular formula who is 56.4% by mass phosphorus and 43.6% by mass oxygen. The target weight is 220 grams. Well, what I've done is simply replace the percent signs with grams and assumed a 100-gram sample. I then set up a mole map problem where I'm going to convert each of those into a mole by dividing by their atomic weight. 31 is the atomic weight of phosphorus, 16 the atomic weight of oxygen. Let's divide grams over molar mass, and I get 1.819. Carry those decimals. Don't round too far or that's when trouble happens. 1.819 moles of phosphorus, 43.6 over 16, 2.725 moles of oxygen. We've learned the strategy to take each and divide by the smallest one, so it becomes a 1. And see how many times the larger divided by small.